Welcome to the deep dive. In today's digital world, it feels like there's just so much information coming at us constantly. Trying to stay genuinely informed, especially with tech changing so fast, it can feel like a full-time job. Our mission here is really to cut through all that noise. We want to pull out the key insights you need to really understand complex topics and, quickly. Today, we're diving into something super critical for, well, almost any modern digital setup. The role machine learning is playing in boosting cloud-native container security. Our guide for this is a really great article from AI News. It lays things out very clearly. So the plan for this deep dive is to unpack the specific security problems that pop up with these container environments. They're different, right? And then we'll shed some light on exactly how machine learning offers these sophisticated automated fixes. We're going to show you how this tech is fundamentally changing how companies protect their stuff online. If you want to keep up with cutting edge tech and what it actually means in the real world, this area of cybersecurity is just crucial. So let's get into it. Okay, so to really get a handle on container security, maybe we should step back first. See where containers even came from in the whole computing evolution story. If you think back to the early 2000s, those much more powerful processors started this whole revolution, didn't they? Led us towards the cloud. And suddenly, one physical server could run, dozens, maybe hundreds of virtual machines, VMs, all at the same time.
Yeah, that was the big shift. And what VMs really brought to the table was flexibility. They were just so much more adaptable, scalable, agile compared to, old school bare metal servers. Businesses could suddenly run lots of different services without needing a separate physical box for every single one. Huge change. But like the article points out, VMs still weren't perfect. They had inefficiencies. Running a whole virtual operating system for every little app, that could be serious overkill. Eats up a lot of memory, a lot of processing power.
Right. And that's where containers step in as the next evolution, as they call it. People always say they're lighter, more agile. What does that actually mean for an application?
Exactly. They are significantly lighter. They need less memory, less processing power, because fundamentally, they only pack up the essential bits of the application itself and whatever it directly depends on, nothing extra. So yeah, that makes them way more agile. And it's this lean design that really unlocks things like microservices.
Microservices. So breaking big apps down into smaller, independent pieces.
Precisely. Small, independent services that all work together. And that modularity makes scaling much easier, scaling up or down, depending on what you need at that moment. Now, it's important to remember that VMs and containers still share a lot of the same basic security problems as, just running stuff on bare metal. Like if there's a bug in a certain version of MySQL, well, that bug's going to be a problem, whether it's on a physical server or inside a container running that version.
Okay, so the foundational security stuff still applies across the board.
Right. There's that base layer of cybersecurity concerns. But what this deep dive really focuses on is how containers and the tools used with containers bring in this whole new layer of specific risks, things unique to them that really need a closer look.
Okay, so containers give us all this fantastic agility, but where does that agility actually start causing these new security headaches? What's the biggest blind spot you see containers creating?
Well, I think a major one stemming from the complexity, especially when you build apps from lots of containers, is misconfiguration. It's just, incredibly easy to get something wrong. The article really hammers this point. Sometimes just a single line in a .yaml file, those common config files can accidentally grant way too many privileges.
And boom, your attack surface just got way bigger.
Exactly. And it mentions a specific example, this too common practice of running Docker as root without user namespace remapping.
Okay, let's pause there. User namespace remapping, that's a key security feature, isn't it? It basically keeps the container's root user separate from the actual host machine's root user.
That's exactly right. It limits the blast radius if a container gets compromised. Without it, an attacker who gets root inside that container, they could potentially get root access on the entire host machine.
Wow, that's a massive risk from just one line of configuration. Scary stuff.
It is. And then another big one is the risk from vulnerable container images. Developers, often under pressure, pull images from public places like Docker Hub. It's quick, it's convenient.
But maybe not always safe.
Definitely not always safe. The article points out this process can be really opaque. You don't always know what's inside. Siftig did a study back in 2022, found over 1,600 images identified as malicious in Docker Hub.
1,600 malicious, wow.
Yeah. And that's not all. They also found tons of containers just sitting there with hard-coded cloud credentials, swash keys, and NPM tokens.
Okay, NPM tokens, those are for accessing software packages, right? Node Package Manager. So basically, keys to the kingdom just left lying around in public images.
Pretty much. So you mix that developer pressure to deliver fast with this lack of transparency in public registries.
And you end up building apps with components that are insecure or maybe even deliberately malicious. It's almost like, I don't know, building a house with untested materials you found online.
Huh. That's actually a pretty good analogy. It really brings up questions about, supply chain security in software. And it doesn't stop there. Beyond the individual containers, you've got the orchestration layers, tools like Kubernetes.
Right. Kubernetes is everywhere for managing large container setups.
It is, and it's incredibly powerful. But it also adds a ton of complexity, especially in larger projects. And guess what complexity often leads to?
More misconfiguration.
You got it.
Yeah.
More potential for misconfiguration. The attack surface grows again. There was this D2IQ survey in 2022, found something pretty startling. Only 42% of applications running on Kubernetes actually made it into production.
42%. That seems really low. Is that all down to security fears, or is it just hard to manage?
Well, the survey said it was partly due to just how difficult administering these large clusters can be. And there's a really steep learning curve. Ari Weil from Akamai put it nicely, quoted in the article, Kubernetes is mature, but most companies and developers don't realize how complex it can be until they're actually at scale.
So the very tools enabling this scale can become weak points if you're not super careful.
Exactly. It's a double-edged sword sometimes.
Okay, so we've laid out some pretty significant unique challenges with containers. Misconfigurations, vulnerable images, complex orchestration. It sounds a bit daunting, but this isn't just a story of doom and gloom, right? This is where machine learning comes into the picture as a kind of proactive defense. How does ML start tackling this?
Yeah, this is where it gets really interesting. The fundamental way ML helps is by understanding the dynamic nature of these environments. What ML algorithms can do is watch an application while it's running clean. They learn its normal patterns, essentially creating a baseline of what normal behavior looks like for that specific app.
Okay, establish a baseline. Then what?
Then, once it knows what's normal, it can spot the anomalies, things that deviate from that baseline and might signal a threat. We're talking about things like unusual traffic, unauthorized changes to configuration, odd user access patterns, and unexpected system calls.
Stuff a human might just miss in all the noise.
Exactly. Especially at the speed and scale these systems operate at. Humans just can't keep up manually.
And it's not just about spotting weird stuff happening live, is it? The article mentions ML helping with prevention too, like scanning images.
Absolutely. ML-powered platforms can automatically scan those image repositories we talked about. They compare the images against huge databases of known vulnerabilities, malicious code signatures, configuration issues, you name it.
And the key is that these scans can be automatically triggered and scheduled.
That automation is crucial. It means you can catch potentially harmful things before they even get into your development pipeline or into production. It embeds security right into the CI/CD process, rather than being an afterthought.
Makes sense. Continuous security.
Right. And plus, these platforms often auto-generate audit reports. They can check your setup against standard benchmarks like CIS, or even custom security policies your organization might have. Super useful for compliance, especially if you're handling sensitive data.
So ML spots anomalies, scans images. How does it help with the response when something bad is detected? You mentioned orchestration earlier.
Yeah, that's the other really powerful piece. These specialist container security tools can connect directly with the orchestration software, like Kubernetes.
Ah, so they talk to each other.
Exactly. Which means when a threat is detected, they can trigger immediate actions. Things like automatically isolating, or just shutting down a suspected container, or revoking permissions that look risky, suspending a user's access. It can even go further. Using API connections to local firewalls and VPN endpoints, these systems can sometimes isolate entire environments or subnets, or block malicious traffic right at the network edge.
Wow, so it's a really fast, automated response cycle. Detection, decision, action.
Much faster and more decisive than relying purely on manual intervention.
Okay, it sounds like ML is offering some serious advantages here.
Yeah.
Are there any, downsides or limitations people should keep in mind? Is it really the magic bullet for container security?
Well, it's definitely a game changer, no doubt about it.
Right.
But like any tech, it's not a standalone magic bullet. You still absolutely need solid underlying security practices. You need people who understand the environment. You need human oversight. ML is fantastic at augmenting human capabilities, automating tasks, handling vast amounts of data.
But it doesn't replace the need for skilled security pros.
Exactly. You still need humans to interpret the more complex alerts, to fine-tune the ML models to understand the context, but for dealing with the sheer scale and dynamism of containers, its ability to learn patterns and analyze data is revolutionary.
So wrapping things up then, what this deep dive based on that AI news piece really shows is how ML is seriously cutting down the risk of data breaches in these container setups. It works on multiple levels, right? Spotting anomalies, scanning assets, flagging those dangerous misconfigurations.
Yes, and crucially, enabling that automated alerting and response, making security much more efficient.
So the bottom line from the article seems pretty optimistic.
Very optimistic. It really concludes that the transformative possibilities of container-based apps, all that agility and scalability we talked about, they can now be explored much more safely. The security issues that maybe held some organizations back before, ML helps mitigate those significantly. So you can innovate with containers, even in really high-stakes industries, without necessarily compromising existing security standards. That's huge.
It really lets organizations embrace cloud native without that constant security fear hanging over them.
Precisely.
Okay, so that leaves us with a final thought for you, our listeners, to chew on. Given how good machine learning is getting at figuring out normal behavior in these incredibly complex container environments and then spotting tiny deviations, what new possibilities or maybe even challenges emerge in how we define and defend against abnormal behavior? Especially as these systems get even more dynamic, maybe even self-adapting in the future, particularly in those high-risk sectors where normal itself might be a constantly moving target. Something to think about.